Our world is just full of maybes, isn't it? But what if we could actually turn that maybe into a hard number? Well, that's the magic of probability and statistics. These are the tools we use to make sense of chance itself. And we're going to start with a question you've definitely heard before.
Right? We hear this all the time. Is it just a random guess, or is there some serious math behind it? This simple, everyday forecast is actually our perfect gateway into understanding the powerful language of chance. Okay, so first things first, we've got to learn the lingo. Think of it like learning the basic grammar before you can start writing amazing stories. This is the foundation for everything we're going to talk about.
At its heart, this is all probability really is. It's a scale, a measurement. It's how we take a gut feeling, a probably or a likely, and turn it into a concrete value we can actually work with and analyze. And here is the first major rule of the game. Probability is only useful for what we call random experiments. You know, things where the outcome's up in the air, like rolling dice or flipping a coin. We don't need probability to know that if you drop a rock, it's going to fall. That's a non-random experiment. The outcome is pretty much guaranteed. Probability lives and breeds in the world of what if.
Okay, so we can figure out the chance of one single thing happening. But in the real world, things are a lot messier, right? Events don't just happen in a neat little line. They overlap, they influence each other. So, how do we handle the odds when things start to get complicated? This slide shows a really crucial difference. Over on the left, you've got mutually exclusive events. They have zero overlap. You can't roll a 1 and a 6 on a single die at the same time. To find the probability of one or the other, you just add them up. Simple. But on the right, things can overlap. You might be a student who also has a job. The formula here just shows that to find the total probability, you add them up, but then you have to subtract that little bit of overlap so you don't count it twice. We call that overlap the intersection. Building right on top of that, we get to dependency. On the left, imagine you pull a card from a deck and you don't put it back. Well, that totally changes the odds for the next card you pull, right? That's a dependent event. But on the right, flipping a coin has absolutely no impact on what the next flip will be. They are completely independent. Nailing this difference is absolutely key to getting your probabilities right. So far, we've been looking at everything up close, one event at a time. Now, I want you to zoom out with me. Because when you take a step back and look at thousands of random events all at once, something really incredible happens. A pattern starts to emerge. And this is that pattern, the famous normal distribution, or what pretty much everyone calls the bell curve. And it shows up everywhere in nature. I mean, think about the height of everyone in your city. Most people are going to be somewhere around the average height, right? And you'll have very few people who are extremely short or extremely tall. You can see the curve is perfectly symmetrical, with the average, the middle value, and the most common value all stocked up right in the center. And this is why it matters so much. The bell curve is like a visual map for our data. It instantly shows us what's normal, what's a little bit unusual, and what's a true outlier. It gives a single piece of information all this rich context. So, how do we pinpoint exactly where something falls on that curve? Well, we use something called a z-score. It looks a little complicated, but the formula is simple. You take the score, subtract the average, and then divide by how spread out everything is. Let's look at Hari's test. He got a 76, which was way above the class average of 68. His z-score of 1.6 tells us exactly how impressive that is. He's 1.6 standard steps above the average student. This is amazing because it lets us compare anything to anything else. It basically turns everything into apples and apples.
Okay, so now we can see the overall shape and the patterns in our data. But we need a quick and easy way to talk about it, you know? We need a kind of shorthand, a simple summary.
And here it is, our basic statistical toolkit. To get a handle on any set of data, we start with these key numbers. We want the mean, that's just your classic average. We look for the median, the value that's sitting smack dab in the middle. And we find the mode, the value that just shows up most often. These simple tools give us a really powerful snapshot of the big picture, super fast. Out of all those tools, I want to zero in on standard deviation for a second. While the range just tells you the total spread from top to bottom, standard deviation tells you how tightly the data is clustered around the average. A small standard deviation means all the data points are huddled up close together. A large one means the data is all over the place. All right, we've learned a language, we've seen the patterns, and we've got our summary tools. Now for the final step, the really cool part, using all of this to find hidden connections in the world all around us.
This brings us to one of the biggest ideas in all of statistics: correlation. It's simply a way to measure if two different things tend to move together. But, and this is so important, just because two things are correlated, it does not mean one causes the other. It's just a clue, a flashing light that says, hey, something interesting might be going on here, and it's a great starting point for digging deeper.
And this slide illustrates the three main types perfectly. You've got positive correlation. As ice cream sales go up, so do sunburns. Makes sense. Then there's negative correlation. As the time you spend studying goes up, your time spent watching TV probably goes down. And finally, zero correlation. The price of tea in China and your score on a math test. They have absolutely no relationship at all. So we'll leave you with a little challenge. From the weather forecast to the patterns in your own daily life, the world is just overflowing with data that's waiting to be understood. Now that you have the basic tools, what hidden connections are you going to find? Because really, that's what this is all about, using numbers to see the world just a little bit more clearly.